February 14, 1942, Harvard University, Converse Lab, basement. In the dim light, a single match flares. Professor Louis F. Fieser touches flame to a small sample of jellied gasoline. It doesn't detonate like regular fuel. It sticks, it burns, it won't go out. In his notes, Fieser logs the key. Aluminum naphthenate and aluminum palmitate thicken gasoline first to an applesauce-like gel, then to something closer to rubber. The 42-year-old organic chemist hangs up his pen and reaches for the secure phone. He doesn't know it yet, but what he's made will redefine combat across the Pacific, able to crawl into caves, punch through bunkers, and destroy what high explosive can't touch. A Valentine's Day breakthrough will become the backbone of the most destructive incendiary campaign in military history. The Pacific War had already delivered a brutal lesson. Japanese troops didn't give up. They dug in. Deep. Volcanic islands were perfect fortresses. Caves honeycombing the rock. Coral-reinforced concrete, miles of underground corridors. Iwo Jima alone held 11 miles of tunnels. On Okinawa, old tombs became machine gun positions. Bombs bounced, shells chipped. Something different had to reach defenders where they hid. That something came from an unlikely place, a Harvard professor known for vitamin K research and blood coagulation studies. A man who'd opposed poison gas but answered when his country called. Louis Frederick Fieser, born April 7, 1899, Columbus, Ohio. He would become, reluctantly, the father of modern incendiary warfare. July 4, 1942, Cambridge, Massachusetts. Not a proving ground. A Harvard soccer field between the business school and the stadium. With the Cambridge Fire Department on edge and tennis players nearby, unaware, Fieser sets 45 pounds of the new compound in a shallow pool. A white phosphorus igniter pops. Globs of flaming gel leap and stick, still burning even in water. Startled players scatter. Nothing douses it. Temperatures spike 800 to 100 degrees C. Fieser's math checks out. This burns 6 times hotter than thermite. Unlike gasoline's big fireball, the thickened fuel can be driven in a tight stream into caves, bunker slits, and pillboxes. Early trials show standard incendiaries kill 1 in 60 attacks. With napalm, it's 1 in 3. The chemistry is the real revolution. Production snaps to life at New England, Nuarex products. By mid-April 1942, a harmless-looking brown powder is shipping. Add gasoline, and it turns terrifying. The Chemical Warfare Service orders thousands of tons. Dow Chemical scales up. By 1943, America produces 500,000 units of napalm. By 1944, 8 million. The M69 is built for it. 6.2 pounds of jellied fuel that spreads across a 15-foot circle. 38 M69s go into an E-46 cluster. At 2,000 feet, it opens and scatters a deadly rain. Napalm's first combat use comes in Europe during August 1943 in Sicily, but its true proving ground will be the Pacific. July 22, 1944, Tinian, Marianas. Captain Robert Johnson of the 2nd Marine Division watches AAF fighter bombers sweep in. They're not hauling standard bombs. They're carrying the Pacific's first napalm loads, shipped secretly from Hawaii. Colonel Kiyoshi Ogata's garrison, about 9,000 men from the 50th Infantry Regiment and others, has carved caves into coral cliffs, with machine gun nests covering every approach and guns hidden on reverse slopes safe from naval fire. When the first canisters burst, Marines on Saipan, just 6 miles away, see something new. Not sharp explosions, but orange fire rolling over fortifications like a tide. The gel pours into cave mouths, bunker rooms, and firing slits. Men who survived weeks of bombardment flee, uniforms ablaze. Water from canteens only splatters it. The only hope is to run. Marine CPL James Chen writes in his diary, "They came out of holes we didn't know were there. It just kept burning. Within days, every advance starts with a napalm strike. Positions that once cost hours and blood fall in minutes." Tinian surrenders August 1st. Of roughly 9,000 defenders, 313 survive. On Saipan, Marines learn that portable M2 flamethrowers can mimic the effect up close, reaching 40 yards. But a man carrying 70 pounds of fuel becomes a target. Once he fires, casualty rates rocket past 90%. The Navy's Seabees answer by fitting Sherman tanks with CBH-1 flamethrowers. Marines call them Zippos. They can project liquid fire up to 150 yards, and armor gives crews a fighting chance. 8 such tanks land on Iwo Jima on February 19, 1945, and their impact is immediate. February 23, 1945. Iwo Jima. CPL. Herschel Woody Williams crawls toward a pillbox through volcanic ash, dragging an M2. Interlocking fields of fire have frozen the line. Artillery and naval guns have failed. At 10 yards, he squeezes the trigger. Thickened fuel pours through the slit. The bunker turns into a furnace. Concrete cracks, rebar warps, a gun barrel glows red, then white. No one inside lasts more than seconds. He finds a 6-inch vent shaft to the next underground complex and feeds fire into the maze. Men erupt from exits 50 yards away, burning. In 4 hours, Williams knocks out 7 major positions. Medal of Honor heroism powered by a terrible new tool. Across the island, the 26th Marines watch a Zippo hurl fire 100 yards into a cave mouth. Flames flow like water through chambers and corridors. The whole mountain seemed to exhale smoke, one Marine says. Positions planners thought would take a weak fall in 20 minutes. The 8 flame tanks drink 10,000 gallons of fuel per day. Seabees like E.M. Joseph Klee and shipfitter J.T. Patterson keep them running under fire. Japanese intercepts start using terms like demon fire and dragon tanks. Survivors later admit bullets and shells they could face. The fire felt alive and unstoppable. By March 1945, napalm is so effective that Maji General Curtis LeMay changes strategy. If gel can clear caves and bunkers, what will it do to cities? March 9, 1945, 5:34 p.m., North Field, Guam, Operation Meetinghouse. 334 B-29s lift off, each hauling 40 clusters with 1,520 M69s. LeMay has fought the jet stream, clouds, and accurate flak at 30,000 feet. Precision from high altitude isn't working. He strips defensive guns to carry more bombs in orders night. Low-altitude runs at 9,000 feet. Just after midnight on March 10th, Pathfinders paint a 3x4-mile residential grid, home to 750,000 people, with an X of incendiaries. The main force follows, dropping 1,665 tons. Fires link in 30 minutes. A firestorm forms. Winds over 100 mph, oxygen ripped from shelters, concrete boiling, steel melting, the Sumida River hissing into steam. Tokyo Fire Captain Susumu Takahashi logs a last message at 12:48 a.m. Fire beyond control. The city is dying. By dawn, 16 square miles are ash. A conservative death toll, 87,500. Japanese sources say 100,000 plus. More die in Tokyo that night than in either atomic strike. LeMay continues. March 11th. Torches Nagoya. 2 days later, Osaka burns for 72 hours. March 16th, Kobe's port and yards are wrecked. In 10 days, incendiaries erase more capacity than 2 years of conventional bombing. Demand for gel outpaces factories. Emergency lines open. By June 1945, monthly output surges. Tactics learned in caves are now applied to cities. April 1st, 1945, Okinawa. If Iwo Jima was hell, Okinawa is worse. 450,000 civilians sit between 100,000 defenders and 180,000 attackers. Latirgennu. Mitsuru Ushijima digs deeper and prepares for flame. Water reservoirs, fire breaks, wet cloth, and mud as crude protection. It doesn't matter. The 713th Tank Battalion shows up as a full flame unit. You have 54 Shermans with Ronson projectors reaching 80 yards. Navy Chemical Unit stock 250,000 gallons. Every Marine Rifle Company carries flamethrowers. At Wana Siege Ridge, reverse slope strong point stop advances for 3 days. On May 14th, Marines roll barrels of thickened fuel downhill, puncture them with rifle fire, and ignite with white phosphorus grenades. The ravine turns into a cauldron. Positions that bled the division for days fall in hours. The moral cost is awful. Civilians sheltering in caves under military orders face a choice: burn inside or run into gunfire. On May 30th, Marines find 450 civilians near Shuri Castle. After warnings in Japanese bring no response, a flame tank fires. Later, Lilfer's John Stevens notes that most likely suffocated when the fire ate the oxygen. Records show flame tanks on Okinawa consume 200,000 gallons. Fortresses that might take weeks to clear fall in hours. Historians estimate at least 20,000 civilian deaths from flame weapons alone, numbers still debated. By July-August 1945, LeMay's B-29s run like clockwork. Intelligence lists 180 urban targets. By late July, 67 cities have been hit. A 300-plane raid can scatter nearly 500,000 incendiary canisters. Each makes a 15-foot pool that burns for 6 minutes, hot enough to melt aluminum. Firefighting collapses nationwide. Fukui loses 60% on July 19th. Matsuyama loses 3/4 on July 26th. Tsu is 85% destroyed on July 28th. Japanese industry plunges. Workers stay home. Rail yards and warehouses burn. Food distribution cracks. Former Prime Minister Fumimaro Konoe writes, "We built a nation of wood and paper. Now they are burning it down." Countermeasures, demolition fire breaks, multi-exit shelters, treated cloth, fail. Physicist Dr. Yoshio Nishina reports, "The gel adheres. Combustion exceeds material limits. Without air superiority, there's no defense." August 1st, 1945. Operation Downfall Planning. With invasion set for November, intelligence counts 10,000 caves and 5,000 bunkers on Kyushu. Casualties could hit 1 million Americans. Plans call for 75 flame tank battalions, 4,000 plus tanks, 5 million gallons of gel, organic flamethrowers down to rifle companies, and rolling firebomb lines ahead of troops. Undersecretary of War Robert Patterson gives flame tank production Manhattan Project level priority. Then the war pivots. August 6, Hiroshima. About 70,000 die instantly. August 9, Nagasaki. The same night, 95 B-29s firebomb Yawata for 2 days. August 14th, while surrender terms are discussed, 160 B-29s hit Kumagaya and Isesaki. August 15th, Emperor Hirohito surrenders, citing a new and most cruel bomb. He doesn't mention the weapon that burned more of Japan than any other. From March to August 1945, incendiaries destroyed 180 square miles across 67 cities, killed 300,000, 500,000 civilians, left 8 million homeless, and erased 40% of industrial capacity. A 1946 NDRC report records 40,000 tons of M69s dropped. The Pacific War doesn't end with a flash so much as with embers. Back at Harvard, Fieser receives the Medal for Merit. His formula shortened the war and saved American lives, but victory tastes bitter. During Vietnam, he watches napalm footage, children running, villages burning, and in June 1972 writes President Nixon urging restrictions. "We aimed at structures and fortifications," he says, "not people." The reply from Edward David Jr., the president's science advisor, is non-committal. Fieser calls it a brush-off. He dies in 1977. Harvard's obituary highlights vitamin K and anti-malarials. Napalm largely disappears from the institutional story. The 713th Tank Battalion is deactivated in 1946. Gear is scrapped. Seabees return to civilian life. Records are sealed. Veterans speak little. Raymond Hart says only, "The flamethrowers got it done." Woody Williams devotes himself to Gold Star families, avoiding details. Eugene Sledge writes, "War makes monsters of everyone. Strategically, technology beats willpower. Chemistry overcomes courage. Industrial output proves decisive. The samurai ideal dies in petroleum flame. Militaries worldwide adopt flame weapons. International law tries to catch up. The 1980 Convention on Certain Conventional Weapons restricts, but doesn't ban, incendiaries. Scientifically, the same aluminum soaps that made gasoline stick help advance polymers, materials, even burn care. Yet moral questions linger. Was Tokyo's firebombing a war crime? Were Okinawa's civilian deaths excusable under military necessity? Did napalm shorten the conflict enough to justify its horrors? Survivors in Japan preserve memories through museums and associations. School children learn about the black snow of burning debris. By September 1945, Curtis LeMay surveys Tokyo and remarks, "We scorched and boiled and baked to death more people in Tokyo that night than went up in vapor at Hiroshima and Nagasaki combined. But it was war. They started it. We finished it." From a Harvard basement to a soccer field test, to caves on Iwo Jima, to cities across Japan, a simple equation, aluminum naphthenate, PLUL, aluminum palmitate, Pols gasoline, scaled into an industrial instrument that consumed an empire. The Pacific became the proving ground for total war, not just via atom, but through a humble gel that burned without mercy. And the questions it raised still burn today.